Hello everyone and welcome to DIANA Release webinar. My name is Maz and today I'm honored to present the new features and capabilities that we enhanced in our latest release, DIANA 10.2. During the session I'm going to mute your microphone just to avoid the background and the conflict in the noise. If you have any question, you are always most welcome to use the chat box, or at the end of the session either message me or use the sign of the hand that I can unmute your microphone and we can have a live discussion about your questions. This session will be recorded and later on you can find it on our YouTube channel or on our relevant page in the website. So end of September, we are quite pleased to basically admit our promises to our clients and users and release our major version, which is 10.2. And we learned a lot from the feedbacks from you from 10.1, and we tried to adapt and implement as much as we could in the 10.2 release. So in this session, I quickly go through them. And you're going to see we incorporated many features at different levels of the program, from the general concepts of the program in the pre-processing, the modeling aspects, and also we have improved many features associated to the analysis capabilities. And at the end, we tried to facilitate and add more features towards the post-processing and results inspections. We start with the general developments and implementations that we have. One of the major things is we updated our Python engine based on the latest version, which is 3.6.1. So there are new syntaxes, features, and basically scripts are available. All our supportive documents have been updated, so I want to inform you and notify you if you have any old script or Python. Be aware there are new syntaxes, there are new updates. If you want to know more, please go to our website, check the release notes, or contact our support team for further assistance, and we tell you exactly what are the modifications and updates, or even help you to update your scripts. With respect to theory manual, we have improved and enhanced that in order to incorporate the new theory manual containing the concepts of modeling in DIANA. Specifically, we are migrating from our historical set of books and manuals that we have in terms of the element analysis material towards the more applications and the use of the GUI. So we are trying to gradually go through this transition. And to this end, we have released concepts of modeling in DIANA based on the associated operational features from the GUI, and also the post-processing and the output of the results in the post-processing. So you can find them in the new theory manual. Further on, we have hyperlinked all the necessary dialog boxes throughout the GUI with the icon of help, in order to link and associate all the necessary backup information from the relevant selected function and the corresponding parts from the manual. For large models, we have realized that it would be very helpful and useful if we come up with the concept of hierarchy structure for the shape and shape sets. This way you can accommodate all the individual components of your geometry into one set, and later on in one operation, this is very important, it's gonna speed up your modeling process. In one operation, you can assign the material properties to all the entities belonging to that set. Or in the construction stage, you can select that group or that set that you have already assigned to be active or deactive. This could be a group of beams, columns, or even group of piles that you want to basically assign, or they carry one type of material models or geometry sets or specific parameters. So using this set at the geometry level, it's very helpful in terms of organizing your structure and your modeling process, as well as your setup of the material properties. Further on, this concept also reads what you import from the third-party programs. So if you have some models from the other programs, could be like Revit or CAD model programs, you can import them, and based on their hierarchy, so whatever over there they identified in terms of the grouping, in terms of the structure, those information also will be automatically transferred in DIANA. So for users who want to use with different program, they don't miss anything in terms of the grouping, entities, and also the list of information that are transferred from the third party into DIANA for facilitating your modeling process. With respect to geometry modeling, we have provided lots of features, functions that basically help you to come up with your final model as close as possible to the real case. Among them is to create a fillet and chamfer, and also to remove them. So if you have basically a sharp edge corners, you can use the fillets based on the specifications that are available in the dialog box. You can come with a nice and smooth transitional geometry parts. This really helps you, especially in terms of the localization. Or you can literally remove that and get back to your sharp edge ending of your model. One more thing that we try to basically incorporate in the modeling strategy of DIANA through the GUI is to define a new connection section under the multifunctional tabs that or multifunctional windows that we had. So the advantage of this connection section is you can clearly see all the entities associated to the interface, flow boundaries, spring, and basically tines, hinge. All those informations are automatically be grouped and can be flagged, identified, visualized through the corresponding main features. So if, for instance, in this particular case, we have some sort of interface for the bed joint, you can easily go to the interface section, and by selecting that, you can easily see which part of your model gets highlighted. Likewise, if you want to go for the joints, if you click on the joints, you can nicely see how the joints are highlighted between the cantilevers. Or, as I mentioned, if you are dealing with some sort of flow boundary under the boundary interface, you can click on that and you can see, especially for instance, this particular case is RCC dam, and for young hardening analysis, you want to see the position and impact and effect of your flow boundaries. So you can easily identify them by going through that main header and click on activated group of sets associated to that flow boundary, and you can visualize them. Another feature that we made it available to be identified and introduced through the GUI is basically spring connections. This could be in the surface or the points, and you can take benefit of that and visualize that through the, again, connection section. Likewise for rigid connection, so if you want to tie all your connections with respect to one point, or make kind of a diaphragm type, you can use the rigid connection and again nicely flag and identify them with respect to the master and slave nodes on that particular diaphragm or rigid connection that you define in the model. One more nice feature that we incorporated is basically beam end release, or making a hinge connection for your beam elements. So this picture is very practical, and you can easily identify what is happening here. So you select the corresponding vertices and you say the end of these two or end of this beam at both sides are basically hinged. So that means they don't carry any bending. Therefore, when you do the analysis, you can nicely see in this diagram how the bending moment at the end of your beam gets to 0. So this is a very practical feature that you can incorporate with your portal frames or with other type of frame structures to control the hinge and connections that you have in your model. For ease of use at the geometry level, and specifically for basically plate and shell elements, user can now visualize the corresponding local axis of the geometry. So this is going to be very helpful in terms of defining your loads, boundary conditions, or also in terms of the creating interface in terms of the compression or tension behavior if you know exactly where are the local axes. Further on, you can align them and with respect to the global coordinate and visualize them based on your new alignment. For those who are dealing with the reporting or presenting the model to the authorities or the managers, or also for your future reference, we added a new feature that literally not only measures your geometry, you can label it, and also you can add text for further reference, and this information also can be projected in your report generation feature that we do have in DIANA. So this is a very nice feature that in one geometry you can present your geometry and the associated dimensions, and for instance, if you have any particular text, you can label it, and in one go you can present all those informations. When you import the program, import the model in DIANA, we do have several checks, call it body checks, and based on different features that program gonna go through, can check for short edge, silver faces, small faces, knife edges. So you can not only check the whole model for any of these criterion, you can also change the tolerance and flag those features and parts that are not complying with your tolerance. And for instance, this particular case, if there is a gap here, there is mismatching, there is no connection, or there is some sort of difference in the overlapping, then you need to adjust it, identify it, and basically go through the healing process. A nice feature that we added at the mesh level is 3D visualization of your cross-section. In this 3D visualization of cross-section, you first model everything based on the beam elements, and after that, when you mesh it based on the dedicated section that you have designed, you can nicely see all those shapes in a 3D view. And this way you can nicely control the beta angle, the orientation of them, to make sure that in terms of the sectional property, they are aligned in the right dimension and angle to carry the most based on the design specification. For those who are dealing with the PyRAF foundations, we incorporated automatic rotational DOF for the piles. So this is basically the axial rotation. So it doesn't matter if it's a vertical or battered pile, program automatically considers the axial rotation, so you don't need to worry about that. And also for 3D line interface element, this is a very nice feature that you not only you have one normal, you have two shear along your line interface in terms of the two different direction of your in-plane direction of your shear. Further on, we incorporated the linear layered shell elements and also the associated GUI in terms of the definition of the properties. I will show you in the next slide, and also for the line interface between two shell elements. It's like Janssen law or the joints between two faces. User can define the local axis through the GUI and you can visualize that. As I mentioned, the material assignment of the layer shell now become very intuitive. So through the GUI and corresponding dialog box, you can nicely define those parameters per layer based on their angle, and you can position them in each layer. For curved shell elements with drilling degrees of freedom, we have enhanced the behavior to capture the real torsional effect, in-plane torsional effect due to rotation of, for instance, if there is a pile here or if there is a column here with the rotational dove. So you can nicely see the induced torsion because of in-plane torsion, because of the drilling effect. So this has been improved from 10.1 to 10.2 to capture more realistic behavior. So here you can see the behavior. In terms of speeding the modeling process, we have improved the modeling strategy for cooling pipes. That means you can model the cooling pipes in the geometry model as a kind of embedded process. Therefore, you don't need to worry at the geometry level any discretization of your model in terms of the plane strain or solid associated with your cooling pipe. So you just place your cooling pipes inside your solid model, and when you go through the meshing, program automatically recognize the position of the cooling pipe and internally discretize your mesh in order to match and get aligned with your cooling pipes. For meshing, we have improved the feature of 2D mapping. So for any 4 edges with the matching number of seats, program is bounded to create a map mesh for you. So here you can see there is a nicely mapped and structured mesh generated for any of these panels, which the number of the seats, the 2 corresponding edges are matching with each other. Also for extrusion mesh, now the imprints of the position of the load are basically complying the process, and when you make the mesh, those imprints are part of the loading process, so you don't need to worry anymore when you are incorporating different type of loadings, specifically with the position of the imprints on the extrusion or extruded shapes. Furthermore, we have added the projected force load. This force load is very important in terms of the projection of the wind, snow, on inclined surfaces, on the cables, and also over the curved surfaces. So basically it projects the normals based on the corresponding effective edge or surface. Also, we have improved the position of the out-of-plane loading and also non-conservative loading for the trusses and cables, which are varying by process of construction or loading process. So those information or loadings are basically getting adapted with respect to the position of the cables and during the construction and changing the geometry. We have incorporated 2 sets of, or maybe 3 sets of databases for the ground acceleration based on the NPR, based on the Tokachi and Tohoku from Japan and from the Netherlands. And also there is a platform for importing your own signals and other known signals into the program. Then later you can import them or assign them to the model and scale them based on the corresponding factors. Another improvement that we made available is definition of the quadrilateral force loads, which literally the position of these quadrilateral force loads are reflecting the imprint of your tires, for instance, tires of the vehicles or trucks, and also the difference or the spacing of the axles. And basically your mesh is independent with respect to the position of these quadrilateral force loads. And we use this concept. This is one of the examples on the plane, so we can see the position of the truck and the axles are imprinted and positioned on the, say it like a deck surface. And we use this concept to mimic and simulate the 3D mobile load or moving load, which gets in line with your traffic lane. So you need to have a traffic lane if you want to model that, and basically a relatively straight surface, and program can go through the process of moving load for you based on the dedicated information that you input manually for the reference vehicles. This particular one example is a bridge. You can see how this moving load is going through the process and how the corresponding deformation is changing. At the material levels, we have incorporated two more features. One is frictional pendulum, and another one is high damping natural rubber to control the energy dissipation and the movement of the relative movement of structures. So you can take benefit of that with the very user-friendly dialog box in terms of the input, and use this type of connections in conjunction with your time history or seismic analysis. Further on, for nonlinear behavior of matrix spring, you can use that now only by defining the diagonal parameters for characteristics of your joint. For instance, if you have one connection with nonlinear bending behavior or some sort of rigid behavior, you can control at one direction is rigid, at one direction is semi-rigid, at another direction is literally has a nonlinear bending. You can define the corresponding stiffness for associated stiffnesses for a normal or basically for a bending, and also you can assign a diagram for one of the selected characteristics that you have and use that in conjunction at one joint. So this is very important. So you can define this, you have one joint in 3D, and you can control that behavior in full three-dimensional behavior. We have made a 2D interface related to cracking, shearing, and crushing interface that we had for masonry structures. And this one initially was for shell elements as a 3D and basically plain stress. So it was kind of a 1D line. Now you can model that based on the surface, and you can incorporate it between the solid blocks of masonry. Another feature that we have is the compressive behavior based on the Makiava for the Draka program more clone plasticity. So this is basically on the top of the existing features. Now user also could select the Makiava behavior to capture the compressive behavior. In 10.2, we made the direct input for Kelvin chain and Maxwell chain through the GUI, so user do not need to deal with any script. And now everything is visualized and can be defined in a GUI through the corresponding input fields. Dynamic added mass for shell and beam elements. This is a very useful feature because when you want to model, for instance, double leaf wall, masonry wall, and one of the walls is structural effect and another one has basically a mass effect, which gets contribution towards the dynamic analysis. In one step and in one go, you can consider the second leaf as a mass based on the shell mass, and the other one as a structural. So this way you can reduce the size of your model, the effort of making the model from the geometry, by having these features associated to the beam and shell, because for a beam also you can have added mass of, for instance, imposed from the windows on the corresponding lateral beams or something like that. And you can go through the time history analysis, the dynamic analysis, without having extra elements in your model. We have improved a lot for our Japanese clients, specifically for modeling bond slip reinforcement, which is basically a kind of 1D element for embedded elements and the bond slip reinforcement that can be used for reinforced concrete based on the corresponding specification provided by Japanese Society of Civil Engineering, and also maximum value for the yield stress and the hardening curve that associated to the reinforcement, and also for shear retention. Now we can control in DIANA for the shear retention not only based on the ultimate strain, also based on the energy. So that's extra control feature that can be used in DIANA for more accurate and increasing the precision of the analysis with respect to the real behavior. Further on, we have two dedicated developments, but they are based on the user supplied subroutine. If you need them, you can contact us. We can provide the information to you. The first one is associated to the lateral bond or no bond of the piles when they are subjected to the lateral cyclic loading. So when the pile is going to the, for instance, right, left, and when it basically compresses and the bonds and debonds with the soil, surrounding soil, you can capture that loosening and dissipation of the energy. And the other one is related to the basically the effect of creep and shrinkage and contribution of the concentration of the humidity, age and maturity in the concrete structure. So you can get back to us if you need more information. We can discuss and provide more information about these two dedicated developments. For modeling the reservoir mass on the hydraulic structures, we made the Westergaard added mass input through the GUI, so it's very user-friendly. Now user can select the effective phase based on the corresponding height, based on the reference properties of your fluid. Program calculates the distributed mass from the reservoir, and you can go through the analysis based on this approach. For stress initialization, we have improved, or we came with a new stable condition compared to any other available approaches, and that is we start with the linear behavior of the soil parameters. We go through the equilibrium, and based on the new status, we adjust and adapt the nonlinear parameters in an iterative procedure, and then go through the initialization. So this way there is a it's more robust and solid in terms of the nonlinearity and basically the iterative procedure. For those who wanted to use the GUI while the program was engaged with the analysis, we have made that reach through. And now when the program is busy with the solver and doing the analysis, you can literally go back to the model, you can do modification, you can do changes, and then if you want, you can stop the analysis and state the mesh, because when you do anything about the geometry, loading, boundary, when you change them, you have to always remesh the model in terms of updating the status of the model information, and then you can redo the analysis. Or you can basically, while it's going through the analysis, you can see the results from the previous case, or you can write your report based on the geometry. So there is no limitation. You can go back and do whatever you want from the geometry, meshing, and results inspection. One of the useful features that we added in terms of the applications, and that's about the automatic deactivation of boundary and interface elements in the phase analysis. So by means of boundary, here is a flow boundary, and interfaces also basically, if you have a hanging interface in the phase analysis, for instance, you have an excavation, and when you excavate the hanging interface between your sheet pile and inner part of the soil which already excavated, program automatically deactivates that for you, so you don't need to worry about the bookkeeping of that. And if you're dealing with the flow boundary condition, as long as you're going through the construction and the matches between the two adjacent flow boundaries, program automatically deactivates that and make it available for flow, basically convecting or passing the pressure from one block to another block. So this is very useful. As you can see here, when there are some sort of interfaces between your cantilevers and you go through the sequence of construction stage, or when you want to go for construction stage and you have a young hardening, so you have a thermal boundary condition. So it's very important. You don't need to worry about the boundaries. You just select the active boundaries, elements, and when you deactivate them, program automatically remove them. In a pilot version, we have incorporated and we have made explicit time integration solver available to the users. So this new feature, which is very important, and DIANA is one of the unique and only programs that provide both implicit and explicit solvers in one unit package for you. We have delivered our first pilot version for you. If you want to try it, let us know. We would be more than happy to provide some backup documents, some information, some setup for you. And you can try it and let us know how this helps you in terms of the simulation of your analysis. And later on in our later versions, we will add more features and make it more capable with all aspects which are available in DIANA. Another pilot development is the sequential linear analysis, and the advantage of this compared to equivalent linear analysis is you can nicely capture the post-peak behavior and softening, and you don't need to basically multiply the reference loads by several iterations. So you can use your nominal loads and nicely program automatically goes for the sequential linear and degradation of the stiffness and find a nice path for your softening. Again, this is in a sequence, as a hidden feature is available, and in a later version we will make it available more with all types of elements, combinations, and models. In 10.2, you can now label your outputs for eigenvalue and nonlinear analysis, and in the drop list of your output, you can see your labeled outputs, which are very useful and handy in terms of the identification and inspection of the results. Also, we have a built-in graph for tabular output, so you can select the entity that you want to load for the point or for the elements. You can get a tabular output, and based on the corresponding axis that you have, you can nicely in a one integrated platform get your diagram as your graph for your selection of tabular outputs. In 10.2, user also can specify the basically contour bands. So you can define certain bands for your legend, and program shows the contour within that range that you specify in the model. From the crack index, we make this available also in the based on the global stress. Previously it was based on the principal stresses, and now also this crack index is available for global stress directions as well, which are useful specifically when you're dealing with the young hardening. You can have better insight in terms of the damaged plates. For time-dependent materials, the outputs which are subjected to the maturity or aging, such as young modulus or tensile strength, now you can have those evolution in the output, and you can see how things are evolving during time, and you can monitor that based on your model code or reference that you have in the analysis to see what would be the final gained strength of your structure. Also, you can visualize your cracks simultaneously at integration point at three direction and based on the multiple cracks. So this is also extra feature that you can basically see in DIANA 10.2 in terms of inspecting of your results and cracks in the model. So these are the features and development that we incorporated in 10.2. We always looking forward to hear from you, to share your feedbacks with us. Let us know what else you need in order to speed up your modeling, in order to optimize your workflow. And if there are some specific analysis features that are required, we would be more than happy to hear from you, and we assure you that they will be available in our later versions. You can have access to the release notes from our website and also the recorded session later on from our YouTube channel or the website. So I would like to thank you all for attending this webinar. I'm available if there is any question. I would be more than happy to answer them. Otherwise, you're always most welcome to send me email, and we can share the information based on your requested questions. Thank you for your attention.